So hello everyone. So today is the last lecture of a general principle of isolation of elements. I hope you enjoyed this chapter and 2-3 questions number of student has asked me the doubts. Okay, so I will solve as I get the time, not a worry. If none of the question, if you are not getting answer when you come to the school, I will explain, because I am also not getting a time. That's why I will solve each and every question. Okay, so when it comes to the topic, see, one of the question has asked by the doubts in the previous test. So that doubt, actually today net is not working, so I cannot open that question. One of the student has asked me the doubt. The doubt is see, the doubt is which ligand does not form chelate compound. Beta, which will not form a chelate compound? The condition itself says for chelation, monodentate ligand will not work. If there is a monodentate ligand, chelate compounds cannot be formed. So first option was oxalate ion. Oxalate ion. Yes or no? So COO minus, but it can form a chelate compounds because it's a bidentate ligand. So it can form. Yes or no? Next, ethanamine. So CH3 NH2. So here there is only one lone pair. So it is a monodentate ligand. It cannot form chelate. No, it cannot form chelate. Ethane 1,2-diamine. So NH2, CH2, CH2, NH2. So see, here also bidentate ligand. It can form chelate. Yes, it can also form a chelate. Propane 1,2-triamine. So NH2. Yes, propane also can form. No, beta. Because here there is a one lone pair will come here, and here also lone pair will come here. CH2, CH2, CH2. So they can form a chelate because they are bidentate ligand. They can form a chelate because they are bidentate ligand. This is a monodentate ligand. So by cyclic compound એટલે chelate, close compound ક્યાંથી બનાવશે ભાઈ? એ તો monodentate ligand છે. They can also form a chelate because it's a bidentate ligand can form a close compound. So answer is, which ligand does not form chelate compound? Option number B, because it's a monodentate ligand. Clear this part? First question this. Second question is, which of the following will able to show that cis and trans isomers? But Ma2B2, I told you no, that if you take Ma2B2 will show cis transomers. Now if I am taking like this, bidentate ligand also will show no cis and trans, Ma2B2. If it is like this, no, Ma2B2 here, so they will also form no AB, here also AB. Or I can add down here like this, AB, bidentate ligand, here also AB, bidentate ligand. If I change the position, they can form cis and trans. So they will also form. So whether I write Ma2B2 or MAB2, both are same. Ma2B2 or MAB2, both are same. Both will show cis and trans. But Ma2B2, Ma3B2 they cannot show because we cannot change the position. Cis means same side and trans means opposite side. So Ma3B2 માં કેમ same size કરી શકું? બે ligand same હોવા જોઈએ ને. So 4 ની પોઝિશન હોય, ઇટ ઇઝ એન સ્ક્વેર કોમ્પ્લેક્સ, તો 4 ની મતલબ બે લિગેન્ડ સેમ હોવા જોઈએ. તો A2 એટલે AA ને BB. તો આની પોઝિશન ચેન્જ કરું તો એક વખત સેમ સાઈડમાં આવશે અને એક વખત ઓપોઝિટ સાઈડમાં આવશે. એવી રીતના AB માં બી થાય, A3B2 માં ક્યાંથી થાય, AA2 માં બી ના થાય. So answer will be 3 and 4. If not you are understanding, when you come to the classes I will tell you. Clear this part? So this was a certain question asked by the tuition, students. Clear this part? Chalo. So I hope you understood. So now I am going to the last part of the chapter, and that part is, first we will see vapor phase refining, and then we will see the chromatography method. Okay, and for the vapor phase refining and for the chromatography I will share one link, see in my description. Especially for chromatography I will share the link. See that link, understand that link, you will understand. Clear this part? Chalo. So make a heading, vapor phase refining. See now what we are doing in this. So here which metal should be used? The metals used, metals taken which can easily vaporized in their, when they are in salt form, when they are in its salt solution. Means how to form this? This method is used for such a metals. So first that metals are converted into their salt solution, and that salt solution should be easily vaporized. So first metal should form easily salt, that is okay, and then metallic salt what we have generated, that can be easily vaporized. This is the first condition. Next, so metals taken, or I will write down not the book words, I will write down in my own language so that you will understand easily. First condition is metal should form easily salts. Easily salts. Clear? Second point. The metallic salt metallic salt should be easily vaporized or decomposed. Vaporized or decomposed. This is the main two condition. Okay. So first, that whatever the metal you are taking, that should form easily salt. How? I will show you just now. And second, that whatever the salt we have generated from that metal salt should be easily vaporized or easily decomposed. One and same. Here we are going to study about two methods. First is Mons carbonyl process. Mons carbonyl process, and second is Van Arkel method. Van Arkel method. Clear? This Mons carbonyl process is especially for nickel. Remember this, nickel metal. To purify nickel. Mons carbonyl or Mons carbonyl, they are telling, but it's a Mons carbonyl process. Second is Van Arkel method. This is used for to purify zirconium and titanium. Clear? So in vapor phase refining we are using two methods. First is Mons carbonyl process and Van Arkel method. Before starting to this, see, I have taken MCQ test, and that test I have taken based on the textbook, and certain things I have asked from the outside. You should be good with the giving the answers. Okay. Second, I have taken the theory test. The theory test is completely based on the NCERT exercise. If you read your NCERT exercise questions, on 80% of theory test you can attempt it. So read your NCERT questions each and line to line. Please revise metallurgy of iron, metallurgy of zinc, metallurgy of copper, and Ellingham diagram. Clear this part? So this is very important. Clear? Chalo. So I hope I given you the hint to write down the exam. Prepare for it. To purify nickel. So what are you doing, beta? First we are taking the impure nickel. That is impure. We are reacting with carbon monoxide at temperature 330 to 350 Kelvin. So it will form a complex, and that complex is nickel tetracarbonyl. That complex is nickel tetracarbonyl. Clear? Now that nickel tetracarbonyl is heated nearly to 480 Kelvin. So it will form nickel plus carbon monoxide. Sir, what is this stupid method? It is a stupid method. First I am converting into complex salt, then again I am decomposing it, vaporizing it. So I am obtaining again I will obtain the gas and this solid. So what is the difference? Sir, આનું combine કરીને પાછું આને આ બનાવ્યું, ભાઈ આ બનાવ્યું તો પ્યોર થઈ ગયો. That's it. So you know here what will happen? No, this is an impure nickel when we will react with carbon monoxide. So pure substance only will react. So it is forming compound here, means here whatever nickel is here, this is pure nickel. Impurity will be left behind here only. So this is the Mons carbonyl process. Take a nickel, react with carbon monoxide gas, it will form a complex known as a nickel tetracarbonyl. Again take that nickel tetracarbonyl and decompose it, heat it. You will obtain what? Nickel plus carbon monoxide. So whatever the nickel you are forming, that nickel is pure nickel. That nickel is pure nickel. Clear this part? Take a screenshot. Clear? Chalo. So here nearly 440 also. You see your textbook. I am seeing the competition book. That's why it is 480. Yeah? You can see from your textbook also. See now one Urkel method, you purify zinc and zirconium, this is Zr is zirconium and titanium. What we are doing, we are reacting with iodine, heating with iodine, and we are forming a salts of iodide, that is zirconium iodide. Zirconium iodide, Zri4. Again this zirconium iodide is heated to nearly 1800 Kelvin. So it will form what? Zirconium plus 2 iodine. Here also 2 iodine. So here zirconium was impure and here zirconium is pure. So this is the method to purify the zirconium metal. Zirconium is first reacted with iodine to form a salt, that is zirconium iodide, Zri4. Then that zirconium iodide is heated to nearly 1800 Kelvin to form zirconium and 2 moles of iodine. Clear? So this is your vapor phase refining. See here we are converting in terms of vapors. No? This is a one salt. This is heated to form some vapors. So what will happen? And this is done in a distillation tube. If you read your textbook, number of things are given which are useless thing, but read it, you will understand it. Okay. The main topic based on this is the reactions. So see, vapor phase refining, metal should form easily salts, and that metallic salts which are formed should be easily vaporized or decomposed. So you take a nickel which is impure, react with carbon monoxide, it will form a salt known as a nickel tetracarbonyl. Now that nickel tetracarbonyl is allowed to heat to nearly 450 to 440. In your book they have given 450 NCRT, competition they have given 480, so I have written 480. So 450 Kelvin temperature, so they will get decomposed to form nickel and carbon monoxide, so that nickel will be pure. Okay, so in short I am doing this process to remove the impurity. Now what happens actually? Nickel is impure here, this nickel is forming its complex. You know from standard 9 that pure substance only made to react, means this nickel is reacting here to form a compound, means from this impure nickel only pure nickel will react with this carbon monoxide and forms this complex. Yes or no? So impurity will leave behind here only. So here complex is form of now nickel, but I need nickel. So I have to remove this complex which is generated, that is carbon monoxide. So again I am heating this. So when I heat this at 450 to 430 Kelvin, I will obtain nickel plus carbon monoxide, but that nickel is a pure form. That nickel is a pure form. Second method is a one Urkel method. That one Urkel method is to purify zirconium and titanium. So zirconium, instead of here titanium, you will get the answer for titanium. I have written for the zirconium. So instead of Zr, if you write down here titanium, so you will get the answer for titanium. So in titanium iodide will get titanium, here titanium pure titanium you will obtain. Clear this part? Are you understanding or not? So that's it. Now next we are going to see chromatography method. Point number 2, chromatography method is not important. It's not so important, but you have to check it out here. It's easy. Chalo. I will share the video. You can see to it. Chromatography method. See, for this first you will understand the principle. What is the chromatography method or principle says? This method is based on that this method based on the different component of a mixture. Different component of mixture are adsorbed, are differently adsorbed on an adsorbent. And this adsorbent, adsorbed, you are not listening first time surface chemistry you are done. Okay, now on an adsorbent. Clear? This method is based on a different component of a mixture. Suppose a mixture I have formed A, B plus C. By taking 3 components, I have formed one mixture. So this mixture are adsorbed differently on n adsorbent. N adsorbent matlab only one adsorbent we are using here. Only one adsorbent we are using to separate these 3 component of a mixture. Only one adsorbent. See, so here what will happen? Here we have two things. One is stationary phase we have, that will act as an adsorbent, stationary phase, and one is mobile phase. Mobile phase means which is moving, no? So that we call as a mobile phase. So in stationary phase we are using a adsorbent like we are using alumina, yes or no? Adsorbent like alumina, silica gel, etc. And mobile phase we are using certain solvents like acetone, simple water also it will work, benzene, then we can say toluene, yes or no? Then we can say chloroform also it will work. Clear? Now what we are doing, we are taking on a tube like a structure, like an injection we are taking something. Okay, and inside we are filling a adsorbent like silica gel, whatever may be. Clear? And on the top we are keeping a solvent on the top in a cup like a shape. We are filling the solvent here. So this is a solvent, and I told you what can be the solvent here, and this is my adsorbent. Okay, and here I will put the mixture. Here I will put the, let me take another chalk so that it will be very clear to you, else again you will have certain number of doubts. I will put here mixture of the component. Okay, it contains mixture of A plus B plus C. As I start to put the solvent downside, so this solvent will react with this A plus B plus C, and this here it was a mixture, so this solution will fall downside and they will form certain layers of different mixture, say it will form here A, it will form here B, here it will form here C. So first C will move outside, then B will move outside, then A will move outside. So I have separated the component which were present in the mixture. For example, you are going for the blood test. Forget blood test, urine test. After the urine test, they are clearly telling you this much urea is present, this much cells are present, this much, or you can say blood test. Chalo, blood test is simple test, you know. So when you are doing the blood test, clearly they are telling these are your RBCs, these are your WBC, these are your platelets, yes or no? This much is your infection. How they can tell separately and so accurately? By using this method. For example, this mixture is blood. In your mixture, blood mixture, there is a presence of platelet, WBC, RBC. Suppose this is a platelet, WBC, RBC. This whole mixture is a blood. I am putting here blood. And for particular solvent, I will put that particular solvent will be given, and they know, one who is running the laboratory, they know that in which particular solvent blood will be soluble. So this is the blood which contain three components, platelet, WBC, RBC. Solvent will be put, as a solvent will put the soluble, these three will start to soluble. So different components, solubility is different. Out of these three different components, A will be more soluble, B will be less, and C will be very less. So one who is more soluble will remain on the top. One who is very less soluble will be removed out first. So they will form a different layers, yes or no? So as I put the water on this blood, so they will get start, this all mixture will start to dissolve. different component will show different solubility. One who is more soluble will be remaining on the top, least soluble will come downside. So in this way I have separated from a blood WBC, RBC and platelet. So this is the modern technique to separate the different component from a mixture. This is called as a chromatography method. Clear this part? So now things come, if I say the solubility of A is more than compared to B, then C, then this position will arise. So I can say that the component which is least soluble. Now beta, from this who is least soluble? This C. The component which is least soluble will move first, will move fast, will move out first. જે સૌથી ઓછું સોલ્યુબલ હશે સૌથી નીચે આવી જશે, સૌથી લીસ્ટ જાજુ સોલ્યુબલ હશે છેલ્લે નીકળશે. and the component which is more soluble will be last, will move out last. In this way I have separated. Understood? So which is the mobile phase? See, this solvent is moving, no? So that is a mobile phase. This is remaining standing. So this is a stationary phase. Clear this part? So in this way I have separated A, B and C. Here I am using this column. This is a glass column. In this glass column I am using certain adsorbent. Now I have done the chromatography by using the column. So this chromatography is known as a column chromatography. Column chromatography. If instead of, so I have used to separate the components by using column, so we call as a column chromatography. If I would have used the paper to separate the component, so there is also paper chromatography. Paper chromatography, yes or no? If I would have used gas, so gas chromatography, glass, number of things are there. So I have paper chromatography, gas chromatography, column chromatography. So this name is coming on based on what? On what thing I am using to separate. Here I am using column and adsorbent as a stationary phase, so column chromatography. Paper chromatography means paper will be the stationary phase. Gas chromatography means gas will be the stationary phase. Understood? So here there is a mixture I have to put on the top and solvent. As I start to put the solvents, so this all the three components are soluble in this solvent. All three components are soluble, but the solubility rate is different. One who is more soluble will be remaining on the top, and one who is the least soluble will be remaining at the bottom and will be removed outside. One who is medium soluble will be remaining in the between. So slowly I can separately out three of the components, means I have separated. Now I can use one example for paper chromatography also. Suppose your small things I will take here. You are having a red ink, suppose red ink at your home. Now that red ink is made up of number of colors. Say red ink is made up of blue plus pink, suppose, plus yellow. So when I have taken blue plus pink plus yellow, I obtain one ink is known as a red ink. But you have a red ink. Now you want to know that this red ink is made up of which other component, blue component, pink component, yellow component. How to take? Or I can take here, suppose here there is a pink ink and I am telling here red, chalo. So you have a pink ink and you want to know that this pink ink is made up of which component color. So what do? You will take one filter paper, you will draw one line here about 1 centimeter top and you will put here this pink ink here, and this paper you will drop in the water in such a way that it should not touch that line. After some time what will happen? After some time the water will rise up. And this dot, this will also, as the water will rise up, this ink will also rise up. So this ink will be distributed in colors. So different colors will be observed here. Suppose here you observe here blue, you will observe here red, here you will observe here yellow. So from this you can say that, oh, whatever the ink I have put, so this will be flowing like this. I will show the video. You see the video, you will understand in detail. So this will be red, blue and yellow. So you can see that, this pink ink was made up of actually three colors, that is blue, red and yellow. One who will be more soluble, they will remain nearly, yes or no? So yellow is more soluble and blue is less soluble, so he has gone very speed. Similarly C was the least soluble, so he has come first. So the component which is least soluble will move out first or will be in the bottom, and the component which is more soluble, मतलब जाजू छोटेलू रहसे, जाजू ऊपर रहसे, so will be removed out last. Means A will be moved out last. So this was your chromatography, simple and sweet meaning. You can read from the textbook. It's not so important question. I will share the video also, and I will share the one animated video. Check it out. You will understand easily. So please see through this, and here your chapter gets end. Nothing is remaining now. All the things has been done. From the next class, I will start some other new chapter. Till then, thanks. And if you have any doubt, please let me know. Thank you.